The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mail. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Okay, so this morning, I've got some questions that people wrote in and asked about. So we'll start with those. And let's see here. This is from section 11. Here we go, 11.5. First of all, number 5 from WebAssign. So you can see it over here on the left. This question often confuses students because of the way that it's laid out. The problem is down here in this step where there's the red X, what the WebAssign people are doing is they're saying, okay, here you've got 1,000 e to the 0.2 power. Then in the next step, they give you this quantity in parentheses. Well, if you take e to the 0.2 power, you get this quantity in parentheses. So what they're wanting you to do is say that, oh, this 1,000 would be the number that goes in the box. Okay, but because of the way that we tend to do it and figure out the whole thing on the calculator all at once, people tend to write this answer when what WebAssign wants is just the piece that's e to the 0.2 power and then times 1,000 and then the final answer here. So it was just a matter of breaking it down into different pieces. Okay, hopefully that's helpful. So for number 5, they were looking for 1,000 times whatever e to the 0.2 power is, and then taking it from there. Okay, so let's go on and take a look at number 33. Let's see here. So this again is section 11.5, number 33. It says, assume that there are no deposits or withdrawals. An account now contains $11,120 and has been accumulating interest at 4% annual interest, compounded continuously for 5 years. Find the initial deposit. Okay, so we're going back in time. We know the final amount. We want to find the beginning amount. Also, because it says compounded continuously, we're going to use the formula for continuous interest. So our formula is going to be A equals P times e to the RT power. Okay. The $11,120 is the final amount. So $11,120. The interest rate is 4% or 0.04. Compounded continuously, time is 5 years. They want to know the initial deposit, so that would be P. Okay, so putting these numbers in to replace the variables in the formula, we get the following. $11,120 equals P times E to the 0.04 times 5 years, okay, which is $11,120 equals P times E to the, so let's see what 0.04 times 5, helps if you turn the calculator on, 0.04 times 5 is 0.2 power. So now we're going to divide both sides by e to the 0.2 power. So P equals 11,120 divided by e to the 0.2 power. Okay, so 11,120 divided by e to the 0.2 power. And I get 9104.285974. Now, this is money. And it says round your answer to the nearest cent, which would be right there. The 5 would round up, so we'd have $9,104.29. Any questions on that, Russ? Oh, okay. Let's take a look at number 35. So this is still in section 11.5, number 35. It says, Kuwait, located at the head of the Persian Gulf, has one of the greatest population growth rates in the world. Bulgaria, in southeastern Europe, has one of the smallest. Use an exponential growth decay model to complete the table. So basically, A equals PE to the RT. Okay, round your answers to the nearest integers. So Kuwait, the population in 2010 is 2,789,132. So P, the beginning population, 2,789,132. The annual growth rate, R, is 3.501%, which is 0.03501. Estimated population in 2019, so that's 9 years later. So T would be 9 years. Okay, so A equals 2,789,132 times E to the 0.03501 times 9 years. So I can put that all into the calculator at the same time. So 2,789,132 times E to the parentheses 0.03501 times 9, close that up, and I get 3822178.073. This would be the nearest whole integer. The 0 would round down. So 3822178, 3,822,178 would be the estimated population in 2019. Now let's take a look at the second half of that problem, which is Bulgaria. And let's see here. Bulgaria, the population is 7,148,785. The annual growth rate is actually negative, so it's decreasing, negative 0.768%, which is negative 0.0, let's see here, over 2 places, 0.768. Is that right? 1, 2, yeah. Time is still 9 years. So A equals 7,148,785, E to the parentheses negative 0.00768 times 9, and I can do that all at once. So 7,148,785 times E to the negative 0.00768 times 9, close it up, and I get 6,671,351.16. Here's the nearest integer. The 1 in the 10th place would round down, 6,671,351. So 6,671,351 would be the answer to that problem. Okay. Let's see here. Did I do? Yes, I did. Okay, hang on. I'm going to switch screens for just a minute. And I'm going to go to another student's questions. Let's see here. 11.5. Number. Okay, so now Basically, this is the same question that the other student had, only different numbers. So we'll go ahead and we'll do that one. So this is 11.5, again, number 35, but now different annual growth rates presented and a different time. Estimated population is 15 years later. So again, we're going to use A equals P times e to the RT power. And let's see, Kuwait, the population, so P is 2,789,132. The annual growth rate now is 3.501%, which is 0.03501. And the time is now 15 years. So A equals 2,789,132 times e to the 0.03501 times 15 years. And we do that, 2,789,132 times, oops, once again, you have to turn the calculator on for it to work. 132, second natural log, 0.03501 times 15. And we get 4715620.159. The one rounds down, 4715620. So 4,715,620. And then for Bulgaria, population, 7,148,785. Annual growth rate, negative 0.768%, which is negative 0.00768. And the time, again, on this problem is 15 years. So A is 7,148,785. E to the negative 0.00768 times 15. And let's see, 7,148,785 e to the negative 0.0068. I left out a 7 here. My bad, right there. Yeah, let's try that again. I left a space there, but this number needs to go there. So 7,148,785 times e to the negative 0.00768 times 15, close it up, and I get 63709, 0.61. The 6 rounds up, 6370911. 6,370,910. Okay, so that concludes the questions that students asked. So give me just a second here. All right, so again, I'm going to go ahead and send you to my YouTube channel. So here we are at Math with Mayo, and so for, let's see here. Hang on. Here we go. Playlists. Take a look at Math 95 Spring and come down here to where we have section 11.6 and 11.7. Apply both sides. Anyway, and in section 11.6, we just have one formula we look at called the change of base formula. You'll see that on the video. And then 11.7. Tonight's homework is to complete a few problems from 11.6 as well as 11.7, the chapter review. Tomorrow we'll review for the chapter 11 test. You'll take that test on Wednesday, and then Thursday and Friday of this week, we'll review for the final, which is on Monday, December 6th. So having said all of that, I am now going to stop the recording. Have a great rest of the day. Bye.